Hello viewers, in this class we'll be learning about what we call trig identities. That is, we'll be learning how to solve these two questions on the board. Okay, they are questions under what we call trigonometric identities. And when we talk about trigonometric identities, trigonometric identities are equations that involve trigonometric functions and are true for all values of the variable. So if the variable is theta, okay, that means the value of the trig function will be true for all values of theta. Okay, now we have two questions, like I said. With the first question read, find the exact value for cos 75 degrees. Okay, then Roman numeral 2, eliminate theta from x equals to 2 plus tan theta, y equals to 2 cos theta. This is more like a parametric equation, but the question asked is for us to what? Get rid of theta, from the two equations, and let's see how that can be done. All right, so find the exact value for cos 75 degrees. Okay, to be able to find the exact value for cos 75 degrees, now Roman numeral 1, okay, is for us to what? To find exact value for cos 75 degrees. Okay, now the exact value for cos 75 degrees, to be able to find the exact values for this guy, okay, then it means we'll have to express cos 75 degrees as the cosine of the sum of two known angles. Okay, what I mean by two known angles, I'm sure we know what we call the similar triangles, where we have sine of 45 degrees, sine of 30 degrees, sine of 60 degrees. 30, 45, and 60. These angles are similar angles. Okay, I mean they are, in the similar triangle we have 45, we have 45 degrees. Okay, we have the what's it called, the 30 degrees angle and 60 degrees in the same equilateral triangle. When we draw equilateral triangle, the two slant sides, okay, we have two units, and also the closing side of the triangle, okay, will also be what? 2 units. But when we drop a perpendicular line, okay, from this point, from here to the base, okay, to the baseline, okay, then we're going to have the 2 units will be what? To be divided into one unit. Okay, so in this case we're now going to have, of course, the angle here will be 60 and this will be 60. So because this line divides this, now this perpendicular line divides the horizontal line into two equal parts, so it means the angle here will be 30 and the angle here will be what? 30. So we can use this to obtain the value for sine 30 degrees, cos 60 degrees, cos 30 degrees, sine 60 degrees, and tan 60 degrees. And also we're also going to employ the use of what we call the Pythagoras rule. Okay, because having known that this is 2 units and this is also 2 units, okay, the third side here, okay, when we square this and we square this, okay, and the square of this is 4, the square of this is 1, 4 minus 1, that's 3, so this will be square root of 3. Okay, so now, like I said, to be able to find the exact value for cos 75 degrees, first we need to express cos 75 degrees as the cosine of the sum of two known angles, like 45 degrees and 30 degrees. When added together, that will be 75 degrees. So in this case, we can write cos 75 degrees to be equals to cos 30 degrees plus 45 degrees. Now, to be able to expand this, this identity, okay, we need to understand that there are some what we call important trig identities, like the Pythagorean identity, sum and difference formulae, double angle formula, triple angle formula, half angle formula. When we also have what we call the periodicity of trigonometric functions. But now in this case, we're going to make use of the one we call the compound angle formula, that is under sum and difference, and this will be what? That of cos. Now we know that so to obtain this identity, now we're going to be what? We're going to be using, okay, by applying trig identity by applying trig identity. So we know that cos A plus B, because this is sum, will be cos A cos B minus sin A sin B. So let's say A is 30 degrees and then B equals to what? 45 degrees. So that means that cos 75 degrees, which is same as cos 30 degrees plus 45 degrees, will be cos A. A is what? 30 degrees. Okay. Then cos B, which is what? 45 degrees, minus sin A again. A is what? 30 degrees. Okay, then sin B, which is what? 45 degrees. Now, what is the value of cos 30 degrees? Now, cos 30 degrees is root 3 over 2. What is the value of sin 30 degrees? Sin 30 degrees is 1/2. Now, what is the value of cos 60 degrees? Oh no, cos 45 degrees. Okay, cos 45 degrees is root 2 over 2. What is the value for sin 45 degrees? That's also what? Root 2 over 2. Okay, now, so to be able to calculate to find the exact value for cos 75 degrees, okay, so we have, so we want to find the value for cos 75 degrees, so exact value. So cos 75 degrees will now be equals to this. Now, what is cos 30 degrees? Okay, let me write this here. So we have cos 30 degrees, cos 45 degrees, sin 30 degrees, then sin 45 degrees. So this guy will be, so cos 30 degrees is root 3 over 2. Cos 45 degrees is root 2 over 2 minus sin 30 degrees, which is 1/2, multiplied by root 2 over 2. When these two are multiplied, we have root 3 times 2, okay, over 2 times 2, that will be 4, minus root 2 times 1, that will be root 2 over what? 2. So this will be root 6, okay, that is over 4, okay, because 2 times 2 is 4. So we have root 6 over 4, okay, minus root 2 over 4. Okay, so to obtain the exact value, same denominator, so that means cos 75 degrees will be 1/4 of the difference between root 6 and what? Root 2. So this is the exact value. So the exact value for cos 75 degrees is 1/4 root 6 minus root 2. Okay, Roman numeral 2. For Roman numeral 2, eliminate theta from x equals to 2 tan theta, y equals to 2 cos theta. Now, to eliminate theta, okay, we want to eliminate theta. You know, we are given x equals to 2 plus tan theta, and also y equals to 2 cos theta. So the first thing we need to do here, okay, let's call this equation 1 and let's call this equation 2. So what we need to do first is to what? Is to solve for tan theta in equation 1 and also solve for cos theta in equation 2. What I mean solve for tan theta in equation 1 and cos theta in equation 2, what that means is to express tan theta, okay, in terms of x, and also in equation 2 express cos theta in terms of y. So from equation 1, now I know that tan theta, when we are rearrange the equation, we have tan theta to be equals to x minus 2. Okay, that will be x minus 2. Okay, so then also from equation 2, we want to get cos theta. Now cos theta is what? Cos theta will be when we have, that will be y divided by 2. That's, so this becomes equation 3, and y this becomes equation 4. Okay, now let's also forget that one of the trig identities, because we have what we call, like I said, we have many of these trigonometric identities. We have the Pythagorean identities. And when we talk about the Pythagorean identities, you know, Pythagorean identities. Now the Pythagorean identity, the first one is when we have cos² plus sin² equals to 1. Number 2, okay, we have 1 plus tan² equals to sec²θ, okay. Then number 3 is when we have 1 plus cos² equals to what? Equals to cosec²θ, okay. Of course, we can also add this to it, cosθ then sec² equals to 1. Then also cosec²θ, okay, sin² is also equals to 1. Then also cosθ, okay, tanθ is also what? Equals to 1. So these are the what? The Pythagorean identities. So we're going to make use of one of this identity. Okay, we're going to make use of one of the identities. Okay, now we have cosθ to be equals to y over 2. And we know that when we talk about inverse trigonometric functions, we know that when we have 1 over cosθ, that will be equals to sec²θ. And here we have 1 plus tan² equals to sec²θ. So we are going to be using the identity, let me put it this way, 1 plus tan²θ, okay, equals to sec²θ. So it means that 1 plus tan²θ, so that will be 1 plus, what is tanθ? That will be x minus 2, okay, x minus 2. Then when we say tan²θ, that means it will be tanθ raised to the power of 2. So we are going to raise this to the power of 2. Okay, now sec²θ, you know, sec²θ. When we say sec²θ, that is reciprocal, okay, that will be, you know, I said reciprocal of cos. That will be reciprocal of cosθ, okay, raised to the power of 2. Okay, let me write this again as tan²θ. Okay, so from here we can then say that, so we have 1 plus x minus 2 raised to the power of 2, 1 over cosθ. Now that will be 1 over cosθ is y over 2. So we have 1 over 2, okay. Then we raise it to the power of what? 2. Because we have 1 plus tan²θ. And tan² means tanθ raised to the power of 2. And we know that tanθ is x minus 2. So then we have to raise x minus 2 to the power of 2, okay. And because we have 1 plus tan²θ, so it will be 1 plus, you know, square of x minus 2. Then 1 over cosθ is same thing as sec²θ, okay. But here we have 1 over cosθ raised to the power of 2, which is same thing as what? Sec²θ. So what is cosθ? Cosθ is y over 2. But here we have 1 over y over 2. So the reciprocal of a fraction is equals to the flip of the word fraction. So in this case we have 1 plus x minus 2 square to be equals to 2 over y raised to the power of 2. Now let's expand this. This will be 1 plus x squared minus 4x plus 4 equals to 4 over y squared. Okay, and okay, we can leave it this way. So we can just write, so when we now I'm going to multiply this by y squared. I'm going to multiply everything by y squared. Multiply all by y squared. So this will be 1 plus x minus 2 raised to the power of 2 multiplied by y squared is equals to 4. So which means the equation will now be y squared plus y squared parenthesis x minus 2 raised to the power of 2 equals to 4. And this is the equation, okay, which shows that we no longer have theta. All right, that is, theta is no longer in the word. This is in this equation there is no theta, okay, which signifies that theta has been what? Eliminated. Of course, we can also leave it this way. We can also have the equation we can leave it this way, okay, but I prefer to leave it this way. That is, of course, 1 plus square of x minus 2, okay, is what I expanded. Now square of x minus 2 is what I expanded here to be x squared minus 4x plus 4, then plus 1, but it's not what necessary again, okay? Because I decide to what? To multiply the equation by y squared so as to get rid of y squared on the right hand side. So when y squared is gotten rid of on the right hand side, it will come to the left hand side, and it's going to multiply everything on the what? Left hand side. And what we have on the left hand side is 1 plus square of x minus 2, okay? And on the right hand side, we're only going to have 4. So we can then expand, okay, so that the equation can be in this form. And this shows that theta has been what? Eliminated from the what? From the two equations. The noblest pleasure is the joy of understanding. Bye-bye.